So, welcome back to our Science by the Sea series, where we're going to show you how to ask and answer your own scientific questions. So, in the last video, we completed step 1 of the scientific process, finding a question we want to know the answer to. And the question that we chose was, how much microplastic is in the sea at Howth Harbour?
So Neve, how are we actually going to go about measuring microplastics in the sea at Howth Harbour?
So for this experiment, I think we're going to need 2 tools. So something to help us collect the microplastics, and then something to help us to look at the microplastics that we've collected.
So for collecting the microplastics, we're going to need a tool that's going to allow us to separate the microplastics from the seawater.
So something like a sieve or a filter then?
Exactly, something like a filter, but the holes in our filter will need to be smaller than our microplastics, and microplastics are less than about 5 millimeters in size, which is about the same width as a pen. So we need a filter with holes that are smaller than that.
Yeah, and it needs to be something that we can make with tools that we find outside of the lab.
Safety is also a consideration because we're going to be going down to the sea and we want to be really careful that we don't fall in. So we need to keep a safe distance away.
I don't think we have anything like this in the lab, but this is okay because, as we mentioned last week, if you don't have the tools you need to answer your question, you can build your own tools.
So let's have a think and see what we can come up with.
So, we've had a think and we've come up with 3 tools to collect microplastics. Now, we're not going to be able to take all of the seawater in Howth and pass it through a filter, so we will take small samples.
Now it's time to see how well our tools work, and actually, I think I know some people who can help us with this.
So, earlier on in the video series, we were talking about the importance of collaboration and how if you don't have the skills you need to answer your question, it's a good idea to collaborate with people who do. So in this video, we've teamed up with Flossie and the beach cleaners, who are going to help us with our experiment. So before we get started, do you want to tell everybody a little bit about what you do?
Well, we're a beach cleaning charity and we like to educate junior school children and some adults on the problems of the ocean and how we have to protect the sea in Ireland.
We're also linked to conservation trusts in Indonesia, and we take students there in the hope that we can catch an environmentalist out of one of them, but to give them a real frontline experience of what plastic pollution and climate change is about.
So there are 2 reasons why we've teamed up with Flossie and the beach cleaners. The first is because they have a completely different set of skills to us. So while Amy and I are really used to going out to the sea for fishing and collecting our animals, these guys are experts at collecting rubbish and also looking for microplastics. So one of the types of beach cleans that you guys do is a microplastic clean.
That's right, so we offered 3 types of beach cleans, but one of our favourites is the microplastic cleanup, and we literally hand out sieves, and you would, in certain places like Sea Point, people wouldn't think to look, but as you look down, especially in this kind of black dark sand, you can see it speckled with lovely beautiful colours, which is all pieces of microplastic or on their way down to being microplastic even more. And if you just put your sieve in, shake it, the sand obviously comes through and they're left with a beautiful array of plastic, and it's actually really relaxing.
So the second reason why we have invited Flossie and the beach cleaners to help us with our experiment is because while Amy and I are really used to building tools in the lab with the stuff that we have around here, these guys are much more used to building tools in a more sustainable way with items that they can find around the house. You have built your own litter pickers out of pieces of wood, pieces of bamboo from around the house.
Yeah, in Indonesia they don't have enough money to buy actual litter pickers, and anyway, litter pickers we actually use, they break easily and they're not recyclable, which is ironic. So in Indonesia they make their own out of bamboo by just getting 2 pieces of bamboo, 4 small pieces of wood in the middle, and then tying it all together and making a makeshift litter picker. So we took that idea back and we've been doing it in Ireland and teaching children and giving workshops on how you can do it.
So Amy and I have basically come up with 3 different microplastic sampler designs. So we're going to go through each of them and build them, and then we'll test them tomorrow. So the first one is the simplest design that we could come up with, which is just basically a water bottle that's chopped at the bottom, and then we have some tights attached to the end, and we will drag this through the water, and all the seawater will get filtered through the sock and then we'll just have a look and see what we can find. So this is the simplest design that we could come up with. So you're only going to need 4 things. So the first is a water bottle. The second is some tights. The third is a cable tie. And then we're also going to need some rope.
So we're going to need to chop the bottom off the bottle. For this, you're going to need to have a guardian or someone responsible with you for it.
Magic! So the next step is to take our tights and stretch it over the bottle. Like this. So here, it's normally best to use a brightly coloured pair of tights, because then in your sample, if you see any fibres that are the same colour as your tights, you know that that's probably contaminated from your sock. So now we're going to secure the sock on with some cable ties. So the width of our bottle is a little bit too wide to use one cable tie, so we're going to link 2 cable ties together. Okay, so the last part is we're going to make a couple of holes at the top of the bottle and attach a rope so we can glide it through the water.
When you're making the holes, be sure to ask a guardian to supervise you because you'll be needing scissors.
Our holes made, we're going to use the scissors to drag the rope through 2 holes so we can
feed it at the other end.
So now we just tie a knot at the other end and we're ready to go. Before we even test this, what can we think about kind of pros and cons of this method of sampling microplastics?
Personally, as a beach cleaner, I think one of the cons would be that we had to use the plastic tie to make it stick. We could have also used a rope, which might, as some people might have around the house, but since we find a lot of those on the beach, it's a bit upsetting.
So one of the big pros of this method of microplastic sampling is that it's very simple with materials that most people would have around the house. For the second microplastic sampler, you will need a crisp can, some tea bags, a stick, and some hot glue.
So step 1 is to cut off the top of the crisp can. Again, make sure you have a guardian supervising you for this.
So the second step is to take your tea bag. I've already emptied all the tea out of this, and we just cut it so we can unfold it and flatten it out. Now we need to take our tea bags and stretch them over the lid of the crisp can to make a filter, and we'll need to glue them on. So because we've used 2 tea bags to cover the whole area of the crisp can, we're going to have to glue them together and then also glue around the edges. Now we have to attach our crisp can to a stick so we can pass it through the water.
So we're going to stick 2 holes in here to feed the stick through. For that, once again, you're going to need some supervision from a guardian.
And to secure that, we're just going to tie some ropes, tie a knot on either side. So if you're not confident with your knot making skills, you can also use hot glue to seal the stick onto the crisp can. So now we have something that can be dragged through the water.
Knowingly to stick the tea bags on, we don't know any other way than glue or sellotape or use a rubber band. So we'd really appreciate if you have any ideas to leave it in the comments down below.
I think one of the pros of this method is that we will be able to stick it deeper in the water. We can control that. So with the rope, it's going to be hard to push the sampler down. But with this, we can decide what depth we want to sample from. Unlike with the tights, where you can just wash them out and do it again, with a tea bag, you will have to use a new tea bag every time you take a sample. So that's a disadvantage. So the third microplastic sampler that we've designed is 3D printed. 3D printing is a technique where materials are melted down and printed out in layers to create 3D objects. You can find a 3D printer in most public libraries or makerspaces. So if you want to take the parts that we've made and print them yourself and build this yourself, we have the links in the description for the files that you need for that. Or you can also make modifications to our designs and improve it, see if you can change it to suit your own experiment.
If your design that you create works any better than this one, please let us know in the comments below.
This microplastic sampler is based on a filter stack. So what we can do is separate out microplastics based on their sizes by using meshes or filters of different sizes. So what we have here is we've 3D printed a a filter and what's called a retaining ring. So you can take any kind of filter that you have. So we're using this kind of mesh. You can use coffee filters, you can use face coverings, you can use tea bags like we did in the last example, we can use tights. So you take whatever material it is, whatever kind of mesh size you want, put it over the filter, and then use the retaining ring to lock in your filter in place. So the great thing about this is that you can decide exactly what mesh size you want or what kind of plastics you want to look at. So to make the filter stack, we take another one of the same parts, another retaining ring and a different mesh with a different mesh size, and we do the same thing again. Our third filter, we're going to be using an even finer mesh, so we'll collect really small microplastics with this one. So to make our filter stack, we're going to couple these together. So we'll have our coarse filter, then our medium filter, and then our fine filter. So we're going to use binder clips to do that. So make sure that you have the filters the right way around, so there should be space between the filters for the water to flow. This is the final 3D printed part for our filter stack. We have an attachment here for a weight, so that when we throw the filter stack into the water, it should sink straight down. We also have this cone part, which will direct water away from the filter stack as we drop it in. So we only want water to be flowing through the filter stack as we pull it up out of the sea. One of the pros of this method is that it's customizable and anybody can make any changes to it and see if they can improve the design.
And you can experiment with any different types of fabrics to see whether they take in smaller or larger pieces of microplastic. Sadly, one of the cons though is since it is made from plastic, it can release its own chemicals and can turn into microplastic itself, which can contaminate our results.
Yeah, but luckily we've used bright colours again, so if we do see any red fibres or blue fibres, we have a pretty good idea where they came from. So now we have our 3 different microplastic samplers. Tomorrow we will go to Hoth Harbour and test them out.
See which one's best and which one didn't work as well.
Okay, so now we have our microplastic samplers. We're also going to need something that will allow us to check to see if there's microplastics on our filters.
So as we said, microplastics are less than 5 millimeters in size, but they can get even smaller than this. So small that it will actually be really hard to see them by eye. So I think we're going to need a microscope to see them.
And are we going to bring this microscope down to Hoth?
So yes, but maybe not the microscopes that you are thinking of. I have a few ideas. So the first is this USB microscope, which you can find anywhere online for less than €20, and it's really easy to use. So here you can see it's focused on my t-shirt. I have another solution, which probably doesn't require you to use anything new. So you probably have a microscope at home, you just don't know that you do. So this is a standard webcam that you probably have at home, but if we take off the casing, we're able to unscrew this lens, and if we do that, we can turn it into a microscope. So now our webcam will be focused on things that are much closer to it.
We have our 3 samplers and our 2 microscopes. I think it's time to head down to Hoth.
We're here at Hoth Harbour and we're going to test our 3 microplastic samplers. So you can see we're all wearing life jackets because we're going to be very close to the sea and it's very slippy down there. So if you are by the sea testing out these tools, make sure and be very careful.
Flossie, how did you find it? What were the pros and cons of your particular method?
The pros of the bottle microplastic catcher was it's easy to make, and when you throw it in you can just drag it around, which is actually quite relaxing. The cons are it's quite hard to see the microplastic at the end because the sock gets wet and everything like that.
It also looked like it was a little hard to sink it into the water, right?
It was hard to sink it into the water at first, but since we have a 3rd hole in it, it sunk eventually quite well.
Harry, you were using the 2nd microplastic sampler. What did you think of it?
I thought it was brilliant. You could scoop it around really easily in the water. I think it's really easy to make as well. So if you have a tube, or I think you could even use a plastic bottle for this. And then the tea bag is a really great idea because you can actually see, whereas I think with the tights there, it's harder to see. If you're say, out and you visually and you're a child and you want to look for stuff, it's kind of exciting that I can actually see lots of dots at the bottom already, whereas it's harder for Flossie. So this, for me, this is a no-brainer. I love it, and really easy to make and really fun.
I suppose the con of this one is that it's a little bit more kind of complicated to make. There's a lot of extra parts, but I found it really easy to use. It sunk down to the bottom straight away and came straight back up in a straight line. And then you have 3 different sizes of microplastics that you collected, so I'm very happy with this one.
Okay, so when we got back to the lab, we took another look at our filters. This time we used the fluorescence microscope that we have here in the lab. It's very similar to the USB microscope, but because some plastics are fluorescent, and so they light up under this microscope, it's a bit easier to see them. There's some, there's another piece. There's another piece. And there's some more. And what's really cool is that these pieces weren't here on our clean filters before we went out to Hoth. So that tells us that these probably came from the sea. Because now we know that we can use any of our 3 microplastic samplers and collect microplastics. Which is kind of cool because it shows us that there are a lot of different ways and different tools that we can use to find microplastics. But I have a question for you. Which one do you think is going to be the best microplastic sampler to answer our question?
Well, Flossie and Harriet thought the crisp can sampler was the best. They thought it was the easiest to build and use, and because they're a beach cleaning charity, they of course wanted to use as little plastic as possible in their sampler design. For us, I'd really like to know a little bit more information about the size of microplastics that can be found in Hoth. So I think we should go for the 3D printed sampler. It might also be good to take different samples in the area because we don't know if the microplastic concentration is going to be the same everywhere.
That sounds great, Niamh. And now I think it's time to move on to the 3rd step of the scientific process, performing our experiment. And big thanks to Harriet and Flossie from Flossie and the Beach Cleaners for helping us out in this video. You can find them on social media or at their website, links below in the description.